In this video, we've got our section over matrix operations, but we're going to start with a little short introduction to matrices. Matrices, the actual definition is just a rectangular array of numbers, and then matrices is just the plural of matrix. So don't get confused if I use one of those or the others. So here I have three examples of matrices. Okay, so these are just rectangular arrays of numbers, and these are used in a whole host of things. They can make multiple calculations happen very quickly. They're used a lot in programming. And so we're just going to kind of learn some basics here. And so the first thing I want to get is some common vocab. So whenever we're referring to a matrix, we can refer to it by its size. And so what we need to know first is that if I'm referring to a row, these are the rows, but then straight up and down are the columns. And the way you can remember that is columns are what hold up a building, right? And they go up and down. So your rows go left and right, your columns go up and down. And so we would refer to a matrix by its number of rows, by its number of columns. So in this case, we have a 2 by 2 matrix. Here, once again, referring to it by its number of rows, by its number of columns, and we put the rows first. So this would be a, let's see, it looks like it has one row, but it looks like it has 3 columns. So we would call this a 1 by 3. And then lastly, it looks like we have an example here that has 3 rows, but it has 2 columns. So we would call this a 3 by 2. Okay? And so we need to know how to recognize the number of rows and the number of columns because we refer to these matrices by their size. It's called their size or their dimension, okay? Now lastly, before we end this short video, a couple of special matrices. If I ever say a zero matrix, that means a matrix that's composed entirely of zeros. It can be any size, any shape, but if it's all zeros, that is a zero matrix. And then lastly, we have this identity matrix, and this has a lot of useful applications that we'll learn later. But this identity matrix is a square matrix. This one has to be a square. Notice this one's 3 by 3, this one's 2 by 2, okay? And the diagonal column from the top left to the bottom right is ones, okay? If it started in the bottom left and went to the top right, that would not be an identity matrix. It has to look like this. So for example, if I could have a 4 by 4 identity matrix and it would look just like this. I'd have 4 diagonal ones and then all the rest would be zeros. That would be a 4 by 4 identity matrix. So just kind of be familiar with some of this vocab as we move forward.